Gracias.
Testing, testing, please. Someone in the circle can say that you can hear us.
Yes.
So
The slides. Yes.
the first talk of this session is by Alex Pratt. The title is Experiences of Observing the 2017 October 5 Triton Occupation. Yeah, 15 minutes and 5 full questions. I will warn you when you are.
Okay, yellow card. Thank you. We are remembering this weekend the death of Her Majesty Queen Elizabeth I, and it was 25 years ago at ESOP in Cambridge, and a weekend in September, which was the funeral of Princess Diana. So there's two events linking the history of British Isles to ESOP, and I'll mention a happier anniversary at the end of this talk. So this was the occultation of Triton 2017. It was a major campaign publicized by what is now the full Lucky Star team, a pro-am campaign. This was a magnitude 13.5 Triton would occult Mag 17 star in Aries for 2, nearly 3 minutes. You can see the track at the top right there, swept wonderfully across Europe, across all of the major observing groups, North Africa, and across the Atlantic, and also could be observed in the twilight conditions by the friends on the eastern seaboard of the United States. This is my view from C2A, and you can see on the right-hand side, there's Neptune. Its large moon Triton would be alongside. This was in the southwest, about 20 degrees altitude, 24 degrees, with an almost full moon in the south. So not too easy conditions, but I hope to observe from my roll-off shed roof observatory, which is IAU code Z92. And perhaps you can see, looking straight into the picture, there's some trees behind, not very high trees, but the main tree was growing very straggly, and this was close to the path of Neptune and Triton. So inside the observatory, I have a nice Celestron 11 with Watek 910 camera, IOTA VTI time inserter, and Losmandy mount and go-to. But I would run this at focal length f10, but I thought there's a risk with this tree. So as always, prepare, and test. And I did test the conditions, and it was too much of a risk. So I have a portable system with a smaller Losmandy mount and my Celestron 8, you know, the orange one, 30, 40 years old. I set that up F10 with a Watek, the same VTI, my old Losmandy GM mount I had not used for many years, so I had to relearn it, find the controller, check the drives work. And there were problems. Where the Triton and Neptune were, the telescope had moved down on the meridian side, it's on the west, so I decided to change it, to put the telescope on the other side. There's a German equatorial mount, so meridian flip. Also, the Celestron 8 had an old dew shield. This was useless. Dew was forming on the plate. It was near midnight. The telescope was near the neighbors. I did not want to run the hairdryer at midnight to clear the dew. So I had a spare little electric blanket, plugged that in, and that was wrapped around the telescope like a little baby. The dew kept away. I had to record for 1.28 seconds, 0.64 with the Celestron 11, but this was for the smaller telescope. Also did 2 calibration videos because the Lucky Star team asked us to record the field before the event to see the target star and the comparison stars. They could analyze the flux of them before and after and during the occultation. I also took some dark videos. Sky transparency was variable, as was the image quality, and a slight wind. But eventually, I did get a light curve. We have see the noise of the comparison star above, and the gradual fade and reappearance of the star covered by Triton. A gradual event because of the quite relatively thick atmosphere of Triton. A nice resource is SAT-24, where you can see the satellite view and the infrared images. This is from the History Archive. So we can see at midnight, 2017, October 6, quite clear over Europe, except France, United Kingdom, more in Germany. There is thin cloud, thin haze, and darker cloud, heavy cloud over the Alps, northern Germany. And that is the list from the paper by Joana Marques Oliveira. The blue circles are stations which were successful and their data was used in the atmosphere analysis. The red circles also observed, but they did not have good enough signal to noise for the analysis. So mine is at the top there in the UK. Our friends across in Eastern USA got some nice recordings, and also across North Africa and the Canary Islands. There's the samples of light curves from UK observers. Interesting collection. But also for the atmospheric analysis by the scientists at Lucky Star, we have these light curves, Wolfgang and Rui and Maximo. We have a bright peak in the center where they were on the center line. The light of the target star was refracted by the atmosphere of Triton like a lens, and it shot out towards the observer, towards their sensor, giving the peak brightness. Just for interest, Eric Frappard took a number of chords in your Aster and fitted them to a model of Triton. It is known very well. This is not new science, it is known very well. But we got a radius of 1425 kilometers, suggesting that at half light level, this was about 72 kilometers altitude above the surface of Triton. And to complete the process, the agreement with Lucky Star, they produce the predictions, you send observations and your data. So at this time, you were submitting report forms to the Paris team, converting your video files to FITs and uploading those. We now have the occultation portal to standardize the process. From all of your observations, this is what is very important for you in your gardens and your observatories observing this event. All your data was collected here, about 90 or 100 stations observers. And Joanna Marquez Oliveira, this was the theme of her PhD thesis. Supervisor was Bruno Siccardi, and the other professional colleagues. That is the link. See this later in PDF, or we can send you this, the PDF of the Astronomy Astrophysics definitive paper on the structure and seasonal variations of Triton's atmosphere from this collection. And they also, it was very nice, we were sent the link to the PhD defense by Joanna. So yes, it is entitled in French, but all of it is conducted in English. And you can see her presenting details of why we observed Triton, what science was extracted from it. And she's there discussing with Bruno and other professional scientists around the world who were refereeing, assessing her paper. And you know, some science is beyond me, but it is 2.5 hours of fascinating data. So please look at those. Some samples of light curves. Top one there, the detail, 20 minutes, sorry, 20 centimeter aperture or 94 meter, 94 centimeter, nearly a meter. You can see the quality in the light curve and the lower residuals, and comparisons here with the different diameters of telescope, 50 centimeter, 25 or 40. And this is why we're looking for better quality in the light curves for professional analysis. So what can we do better next time? This is not a definitive list. These are just items for discussion. So the predictions are very good now. We have Gaia DR2 stars. We have ephemerides from Horizon, Lucky Star, last minute astrometry. And if we record occultations, they can feed in to improve the orbits. Many use 8-bit cameras, but now we have the QHY 174 and others, 10-bit, 12-bit, 14-bit. We can mix and match, use either. We understand the sensor linearity of them. We set gamma 1 with a digital camera. We can set a region of interest to take a smaller field, get a faster frame rate. But be careful that the number of bits does not drop from 12 to 10 with a QHY if you set a high gain. We have very reliable recording software, IOTA video capture, OcuRec, SharpCap, and others. They are mature, they are good. We have accurate timestamps from GPS systems. More people now using NTP, and they are synchronizing with Linux servers, Raspberry Pi, Timebox. It's all good. We set the exposure time really with simple occultations. We want to record a dip, so we have a very poor signal to noise. With studying an item with an atmosphere, like Triton or Pluto, we need a better signal to noise. So take guidance from the Lucky Star proposal on a scheme. Calibration, they will ask you for dark frames, flat fields, like you do if you do deep sky imaging, and also calibration of the target star before and after the event. It's taking a professional approach to our amateur work. We can analyze manually with IOTA, PIOT, but that is for fun. And please send your data through to in the right format with your raster or your raster 2 or your regional coordinators, and especially to the occultation portal. Now, and to finish, this is the happy anniversary that I found, that we have another Triton occultation. You can see the date, October 6th. This is 5 years almost to the day of our 2017 success. It also is about, well, 23 degrees moon away from the target, but it's also almost full moon, just to try to spoil the event. But it sweeps across Asia. And I looked on watch a cloud, and there's some Japanese observers signed up. And I helped more observatories or professionals along the track here. You can see my geography is hopeless. But Japan, China, we're there to India. Yes, fingers crossed. So that's it. Thank you. Oh, it's just a very high uncertainty on the target star. So it's perhaps not quite perfect from Gaia DR3 or suspected double. But the track will be very reliable. So good luck to anyone who tries that event. Thank you.
Thank you very much for staying in time so perfectly. So we have time for a few questions or comments. I guess we're gonna have one comment because we have time in one telescope in India for this. Yeah, go.
Okay, thank Alex. I'd like to comment this map because we have big telescopes in India, 3 meters, 1 meter. In
Good.
Japan, as you mentioned, but we don't know many people in China. If you have some access or contacts, please let us know. So I know that big telescopes in China.
Yes, good.
If you slide Peterson services, emotional about from the cameras.
Yeah,
But we need a server.
More questions?
and just one other comment. I think you mentioned that the defense was in French.
No, the title is in French, but after that, it is all in English, and it is even for someone who does not have, say, simple school science or physics. Everyone can watch it and understand the science behind occultations on how your observations are used to model an atmosphere of an object like Triton, and what use is made of your data. So I highly recommend it.
Okay. If there are no more questions, the next one is by John Ferreira. I thought things across the campaign for occultations was dark. Target was you have 20 minutes. That's fine for questions.
This works like this, right?
Yeah, it's very like that.
Okay.
Yeah.
People in Zoom, they are claiming that they are looking.
Now it's okay.
Yeah, but we are not. No?
As long as the people from Zoom can see this, I'm fine if it looks like that. Yeah. Yes, for me it's fine. For me it's fine. No.
Okay,
Sure.
we have problems. We cannot show the full screen here. It's being shown on Zoom, but not here. But Joe will manage with the smaller screen.
Entonces la presentación con diapositiva. Claro, no. No, no hay. Bien, no. No hay. No. Ojalá. No, pero no tengo más.
No se puede poner así.
Vale.
Joe will manage with the smaller screen. Sorry.
Okay, hopefully this doesn't cause any issues for you. So thank you all for being here. I will talk to you about the Across team and our campaign for occultations by the DART target Didymos and other near-Earth asteroids. I have many co-authors for this work who I will briefly mention in a slide further ahead. So the question that comes to mind immediately from this title is, what makes Didymos so interesting? I mentioned that it's a DART target, but what is that? This is DART, the DART mission, where you see that a satellite is moving in the direction of a binary system. This binary system, as you can see from the slide after, is Didymos and its satellite, which is known as Dimorphos or Didymos 1. And this satellite is a bit different from other missions because while other missions have always that very tense moment when they orbit an asteroid or they land on an asteroid where they have to land and not crash into the asteroid, this is not what we want. The idea is specifically to crash into Dimorphos as fast as possible. And this will cause some sort of perturbation on the orbit of the binary system around each other. And the idea is to check if this can be a possible method for Earth defense. Didymos is considered is a near-Earth asteroid because it has a perihelion almost at the level of the Earth's of the Earth's semi-major axis, and it has a MOID, minimum orbit intersection distance, from Earth of only 0.04 AU, which is sometimes larger than the lunar distance. It is considered a large NIA. Normally, NIA are considered large if they are above 140 meters. Didymorphos is also above this threshold, but it's much smaller, which means that this binary system is not orbiting around a mutual center of mass that is more or less centered between them, but it is more Dimorphos orbiting around Didymos. As I mentioned, Didymos, the DART mission is a deliberate collision mission where it will impact Dimorphos, the smaller asteroid, to cause a bigger impact. And this collision is happening on September 26th, about 2 weeks from now. And there will be a complementary mission by ESA, because that is from NASA, which is called Hera. This will orbit the Didymos-Dimorphos binary system to validate the orbital change caused by the crash, and its launch date is in late 2024. There are also some possible flyby missions to other asteroid targets. Now, the problem of occultations by near-Earth asteroids is that they are notoriously difficult for two reasons. NIA are small, and NIA are also very fast-moving in the sky, which means that their events are always going to be very short. If you have, by any chance, ever checked an event by Didymos, you will see that its length is always 0.2 seconds or lower, which is very short. So you need to have fast cameras, big telescopes to see the star, unless we are lucky to have a bright star. And the close approaches are also a problem because they make it so the uncertainty of the orbit on the ground for the observers is larger, even if the orbital accuracy is the same. And because of these reasons, there have only been a couple of occultations by near-Earth asteroids registered. I am not including here Eros, which is a very big near-Earth asteroid, which constitutes an exception. And there have been prior results from Phaeton, which is a more or less 6 kilometer NIA, and Apophis last year, which is a very small asteroid, only 180 meters. And this list is incomplete because in August, there was also another one observed for 1994 AW1 as part of the ACROSS project. And the ACROSS team was created specifically for the purpose of observing near-Earth asteroids through occultations. And we had a special focus on Didymos because of the DART mission. Now, here are the main people from the ACROSS team. You have the coordinators Paulo Tanga and Menes Tsiganis. They work in Nice and in Saloniki in France and Greece. We have Damya Swami, who was presented previously in some of the Lucky Star works. There's myself, and then there are other people who I highlight. Alex Tsiakas, who worked more directly with me, a recent master's graduate from AUD. And we have a general contact, which is across at OCA from certada.côte-d'Azur.eu. Now, we have an official website at the Lagrange Laboratory of Nice, which you can visit and check for near future events, as well as campaign results and tutorial videos for the NIA specific observations. We also upload events for the Occult Watcher Cloud, which are tagged under the name ACROSS. And these events can be updated at the request by the observers, because for simplicity's sake, we do a 1 month run for NIA, but because they are fast moving in the sky, this is not very accurate. And so if observers request it, we can make a prediction for a specific event propagated to that date, which will in turn give a more accurate prediction. We use two options for Occult Watcher Cloud. One is the ACROSS orbit, which we obtain through the use of the OrbFit tool. And another one is the standard solution, which is provided by JPL Horizons, which Occult Watcher Cloud queries automatically. Now, for Didymos, there have been many campaigns in the past, specifically in the last couple of months, of which I'm going to highlight 4, 2 in the United States, 1 in Japan, and one that happened very recently in Portugal, Spain, and Algeria. Now, this is the occultation on the 24th of July in the United States. I see that the colors are not the same as in the presentation, So if you can bear with me, the orange lines are the shadow path limits. The center line between those is the center path limit, and the red lines are 1 sigma. This is the JPL solution. And then the other lines, which are supposed to be green, they are the lines that were determined equidistantly for observers so that they can cover the most ground possible and try to observe a positive occultation. Unfortunately, there was no such positive chord, neither on this campaign nor on any others. Here you have most of the observatories in observation sites in Japan on July 29th. Here, once again, the colors are not the same. I'm sorry for the legend. It's not the colors that you see, but you see that there are 2 solutions there, the ones that are covered by blue. The north one is our solution from across, and the south one is the one from JPL. They were very far apart for the United States. Here they were a bit closer, and they tended to get closer and closer because of those last-minute astrometry campaigns that have been mentioned in previous works, which were made intensively in July and August. This is an event very late into the preparation for the August 25th campaign. This was also in the United States. You can see the 2 solutions again, the yellow lines and the blue lines. This is a bit confusing but because of the color differences. You have one observatory site there. There were 5 others, but only 3 registered chords. And once again, they were all negative. But we can see that the orbits were getting closer and closer together, which facilitated the August 25th event. Now, this was an event that was in Portugal and Spain. I coupled them as Iberia and Algeria. This was on August 25th with a magnitude 13 star. This was where most of the observers were focused in Portugal, namely slightly north of Porto. And the solutions are almost touching each other, which once again made it so that the ground we had to cover was a bit smaller than before. Now, there were a total of 40 observing stations prepared. Each of them had at least 2 observers working on them, which means that we had more than 80 people as part of this campaign. And it was a very international campaign because there are people involved not only from Portugal, Spain, and Algeria, but also teams coming from France and Greece, and also the United States, because in the night after this one, there on August 26th, there was an event by Lucy Target, which was Polymele. And so the recon team from the Southwest Research Institute brought a lot of telescopes and people to make the observation with us. And so we had enough material to cover the 3 sigma uncertainty on the ground for the orbits of both JPL and across. So it was virtually guaranteed that we would get a positive event. The only thing that got in the way was bad weather all across the Portugal side of thing. And we have a saying in Portugal that bad luck never comes alone. And so there was also a sandstorm in Algeria, which made it so those observers could not observe anything either. So the only potential results that we have for this campaign of over 40 satellites, 40 telescopes, sorry, is the few telescopes that observed in Spain, mostly focused around the Andalusia region. I encourage you to check out the poster by Javier Flores, who made a poster about this specific campaign in Spain with some of the preliminary results of which I don't yet have access to. The good news about this campaign in Portugal is that at least the Polymele one event was a success. There were, to my knowledge, at least 8 positive chords. And I'm sure that you will be hearing about this result at a later stage from the recon team led by Mark Bui. And so stay tuned for results for Polymele. So now, as I mentioned, the crash of the DART mission is very soon, almost 2 weeks away. And there are fewer chances to observe an occultation before the event. But there are still many September events in Australia which might be observable, as well as one in the Arabian Peninsula and India. And depending on the conditions, you might try to observe Dimorphos as well, although Dimorphos is about 4 times smaller than Dimorphos is smaller than Didymos, which means that observing it will be even more difficult than it already is to observe the parent asteroid. And I will show you 3 different campaigns that are being prepared for pre-impact dates. This is one in Australia on September 12th for a magnitude 16 star, for which there are already at least 3 stations coordinated for the observation. On September 20th, there is this one in the Arabian Peninsula, which we have been preparing for a long time. To my knowledge, there will be at least 6 telescopes preparing for this mission in the United Arab Emirates. And then on September 22nd, there is another event in Australia, this time with a magnitude 11 star, and for which there are also 6 stations prepared. But we will not stop in the impact date, because after the impact, the orbit will change, and we also want to try to register that. And so there are some September events post-impact that are available on Occult Watcher right now, as well as some events in October which have already been propagated for. And there is also another possible synergy with the Lucy target again, this time in France, because there is an event for Eurybates on October 23rd, and events for Didymos in the same region of France 2 days before and after. We are discussing a possibility of once again having a cooperation, but we don't yet know if this is possible. And I want to point out here that post-impact observations will still be essential, because the idea is that we can gather the most data possible around the impact date to check the effects that it will have on the binary orbit. I will show once again a couple of events for post-impact campaigns. This one is on the very day of the event with a magnitude 8 star in Australia, which we are trying to encourage people to observe. This is one of the 2 events in France that I was talking about, one in October 21st, then Eurybates is in October 23rd, and October 25th, there is another one, also in the north of France. Now, as I mentioned, the cross was mostly focused on Didymos, but not only. I also mentioned that ESA's Hera mission has a couple of flyby targets that might be used. This list of 9 objects that are specified on our website, which you can look more into. There was some focus on these events of these targets specifically. They are not all near-Earth asteroids, but they might be flyby targets, so we still focused on them, especially on Francis Muir, which has the addition of recent imaging data for astrometry, as well as Gaia DR3. And since the Hera mission launches only in late 2024, we still have a lot of time to prepare campaigns for these targets. These are 2 events that are for objects in this category. One on September 16th in the United States for 2000 SX69, and one for Francis Muir in South America on September 20th. You'll be able to see this when the presentation is shared. We also have a 3rd list of predictions for good objects, by which I mean a short list of near-Earth asteroids with orbits that might allow for good predictions. The criteria that we used was the semi-major axis uncertainty below 10 to the minus 9 astronomical units, a diameter above 500 meters, but smaller than 10 kilometers to exclude objects like Eros. And then the uncertainty on the ground must both be below 50 mass to avoid big dispersion of observers, as well as having a diameter ratio below 5. Otherwise, the probability of observing it will be very, very short. We also focused a lot on Noir Shalom for the same reasons as Francis Muir. There was a large amount of viable events and recent imaging / Gaia DR3 data. This is an event by Ra Shalom on September 12th, so next Monday, I think, on South America, which also crosses the Great Britain. There is one event by 1999 CV3, which crosses Asia and Africa, and one by Geographos, which crosses Earth and Africa on September 23rd. So one of the final things I will mention is Gaia, because near-Earth asteroids can be used to validate Gaia's DR3. DR2 was published in 2018 and had a small list of data for asteroids. It was kind of our DR1, so to speak. But Gaia's DR3 increased the number of available objects by a factor of over 10, or almost 10, and the amount of data by 1 year, which can bring a paradigm shift for occultations because this will completely change the accuracy of the orbits of asteroids that are included in Gaia DR3. And most of the objects that have been observed with Gaia DR3 with occultations have Gaia DR3 data, so you can incorporate Gaia DR3 into the orbits to check if the occultations and DR3 are compatible. OrbFit, the tool that we use, is compatible with Gaia DR3, and so we have been using this as of late. There are specifically 450 near-Earth asteroids that are present in the DR3, and they could be good objects to validate Gaia because any changes on their orbits are more pronounced than for large objects. So my conclusions for Didymos, there was some tension before between Across and JPL, but they are getting closer and closer together thanks to the addition of new astrometry data. The campaign for the event in Iberia and Algeria was very effective because we could track all of the sites that we would use for the observation. It's just that the weather couldn't permit the observations except for Spain. And the convergence between orbits still leaves hope for some events in the very near future, pre and post impact. For future prospects, we have the campaigns for Didymos pre and post impact, other NEA that are secondary focus for Across. And in the near future, we may choose our targets differently thanks to the very accurate Gaia DR3 data, for which NEA can be a good source to validate the data. And our work does not end with the DART mission because Hera mission is coming and we will still want to produce events for them. And so I leave you with a picture of some of the people that participate in the Iberia event, some of which are here, some of which are probably watching, and I thank you all for listening.
We have time for questions. Mike, approach to the mic. Mike.
Thank you very much for this interesting talk. I have a question. You are mentioning the OrbFit software is not compatible to Gaia 3.
Yes.
In what terms? I don't know what exactly technically do you mean with this.
So I mean that the OrbFit tool was prior compatible with Gaia DR2, but Gaia DR3's data is slightly different, specifically in the way it handles the residuals of the observations. And so there had to be an adaptation before you could use Gaia DR3 data. It was not immediate in June when it was posted, when the Gaia DR3 data was published. This is very recent from last month. And you have to use the Gaia DR3 data in a very specific format that is not the one that you get if you download it from the archive.
Additional question, this new version of OrbFit is available on the server of PISA server? It's upload or is it a specific version?
I don't think it's publicly available yet. We do have access to it because we were in contact with Federica Spoto from NPC and she gave us access. The version that is online, I don't think it's still compatible with this version, only with Gaia DR2. I am not sure about that.
But Federica is maintaining this.
Yes, yes.
Okay, thank you.
More questions?
Maybe from the Zoom, I see one comment. I don't know. No. Okay.
I have a further question regarding what Mike said. Gaia DR3 for asteroids has very high accuracy in the direction of the scan of Gaia.
Yes.
But this changes in different positions of the asteroid. So
Yes.
how do you take that into account, the orbital heating? Because one direction has nice accuracy in astrometry, but the other is very bad. So
This is correct. So for those who don't know, Gaia scans in a long scan, and it is very precise in this direction, but then in the orthogonal direction across, it is very poor because the data is binned to a single number instead of being, I think it's 12 by 12 observations, it's just 12 by 1. And so what we consider is that the asteroids are scanned in different directions, and so the long scan is averaged into being more or less across every possible angle. And I cannot give the specifics of how OrbFit handles this. Just that the team that produced the Gaia DR3 data is the same that develops OrbFit, and so they are the ones who will know how to incorporate this. But the fact that Gaia is more precise in one direction than the other does not mean that the data is poor in one direction, because as I mentioned, you will scan an object in different directions in different periods of time, and so you will end up having good measurements across all angles.
Okay, any other question? I have just a brief comment that because I led the expedition to observe the Didymos occultation here
Yes.
in Spain, and Javier took a quick poster there. Sorry, we didn't have time to provide all the data and do a quick a careful analysis, because we had this meeting also about EPSC coming, so
Yeah.
I apologize that I haven't had time.
It's okay. You're the only ones who have data, so we are very thankful anyway.
But a spoiler, I think we didn't get it, or maybe we got just dimorphos, because we have very short drops. So anyway, I think we have to move on to the last talk of the session by Constantino Sigismondi through Zoom. He will be talking about the refraction of the horizon measured by sunrise and
So the person that will present, please, you can share the screen. Constantino, are you there? You need to. He's not here. Yeah.
can anybody send him the Zoom address quickly? You have his email address and his email or WhatsApp. It's not online.
He's not online.
Okay, you can send him an email, but if he will not read it immediately. I mean,
Maybe we can take the group photo meanwhile, if he's joining.
Yeah.
Because the next item of the agenda for today is the group photo. So maybe we can do the group photo while we try to reach Constantino. Is that okay? Oh,
okay.
¿quién toma la foto? Entonces te la charla. Voy a pedirle a alguien to the patio. We should go to the patio, and Pablo will take a picture from the upper level. So hopefully it will be a nice picture.
Yeah, I also know
Anthony, muéstrame dónde hay que modificar eso.
Pestaña.
Y voy a. We can make a picture from the Zoom participants. So if you want, please turn on your camera and I will make a snapshot. We are waiting Constantino that is not connected on Zoom. So if anybody knows him, you can write to him and send the link.
También debe estar configurado el PowerPoint en distintas pantallas. Y si se configura que el proyector sea copia de la pantalla esta. ¿Entiende lo que quiero decir? No es fan de eso, ¿no?
Okay. I suppose that the other people that they do not turn on the camera, they don't want to take pictures, so I will take the picture now. Okay, done. And if Constantino is not here, we'll go for lunch and resume after lunch. Let's see, or let's go to. Let's see. Yeah.
Mira.
It's not here.
Okay, since Constantino Siglitmandi didn't show up to do his online Zoom presentation, we can either take the time to do some discussion or
Ahora.
or we can make further announcements.
He has an email address. You can send him an email to the Zoom link. And so yeah, I use the time for an announcement concerning the excursion because I got the question. As I mentioned before, we couldn't make all the prices fixed in advance. Now we know it. So how to pay this 50 euro for Palo Alto or this 30 euro for Lamba if you're going to Lamba? Well, it depends, Andreas. If the people should pay to the IOTA account or.
Der eine Kollege hatte schon bar bezahlt im Bus vor. Der Niklas.
Ja, ich habe auch der Lamba-Spiel bezahlt.
Ja.
Das wäre einfach.
Mir ist es egal. Aber
Weil sonst muss jeder mir 30 Euro geben.
das wird Chaos.
Okay. So we recommend that because it would be too complicated to pay to me 30 euros for Lamba and 50 euros to Nico. I think it would be easier that as soon as you're able to do that, you make a bank transferency or PayPal to IOTA to pay this to IOTA. If you have Palo Alto and Lamba, you pay 80 euros. If you just have Palo Alto, you pay 50 euros on the IOTA account, and they will give us back the money we have given to them. Otherwise, you would have to pay now in cash 30 euros to me, and that would be too complicated. It's easier you make just a bank transfer or PayPal. IOTA has also PayPal, and you pay your excursion to that account, and they will give us back the money later. Okay, that's okay for you.
Okay, nur blöd. Aber irgendwie.
I trust everybody. Everybody will pay, the excursion
When you use PayPal, click the button to friends.
to friends, yes, otherwise not the whole money will. Right. Okay.
Okay, that's cost otherwise. I have all the credit cards used in the for zero.
Try to come back also a bit earlier. I don't know if the speakers for the afternoon session will be ready. Yeah, Bern is here. But the people through Zoom should be advised that maybe we will start a little bit earlier. 15 minutes. 15 minutes, or I think it's best if we stick on the agenda, because people who are outside may not have heard this. So we stick with the agenda, and we will resume at 2:30. Okay. We will resume at 2:30.
Yes.
But no,
So
which is the presentation?
Go for tapas and
Complete ESOP42.
Okay. I will do, this is
not
my,
reading a single correct.
yours is on the afternoon.
Yes, the first one.
So I will copy everything here. Okay.
And I like to check it.
And?
I like to check it.
Okay, yes. So which file?
Down.
So it's on the web. Using that.
It's written on.
So can we leave it?
Yes.
So I need to stop.